This conference will now be recorded.
My screen. We'll start the session. Let me know when you can see my screen.
Yeah, Venkat, I can see.
Okay, sure. So yeah, so two topics for today. One is aggregate planning and another is the forecast consumption. So first talk about the aggregate planning. Um, Aggregate planning is being supported by the optimizer only, and and this is not a typical aggregated planning, but uh, this is more like you are constraining at an aggregated level. Okay, so there are a lot of constraints, right? In optimizer, we have seen it in our scenarios, like inventory target is a constraint. Capacity, supply is a constraint. Minimum key figures are there. That is a constraint. Maximum key figures, those are constraints, and there are such kind of a constraints, and every constraint was at a particular level, so we need to go and pick up that key figure and maintain it, and system would give us the right result. For example, um, if you want to constrain on a transportation lane that is from a plant 1 on a particular week when it is sending to DC, so if you say that my adjusted transport receipts is 111, so for that time bucket on that particular transportation lane, and again for the product that we specified, the supply planning output would be same as adjusted transport receipts. Okay, so those are that's how we play with the constraints, and then we maintain the value, and then the optimizer will respect it, and depending upon the constraint type. For example, like some constraints are hard constraints, some are pseudo hard, and some are soft constraints. So we talked about it like on day one, right? So like adjusted key figures are like pseudo hard constraints, so those would be respected a majority of the times. whereas capacity supply, that is how much available or how much of the capacity is available, that is a hard constraint. So that would be never violated. So if you say that this plant can only produce this much, and because this is available capacity and that's it, so it will never be compromised. So that's the thing with the constraints, and how we have to, how we can tweak them, and how we'll get the desired supply plan. Okay, now we have another bunch of key figures. We call them as an aggregated key figures, and by using them, we can actually do an aggregated planning. Okay, how we uh, do that. Let's see it. So there are eight key figures. I mean, in total, they are uh, actually there are 12. We always have the supply part of the key figures, right? I mean, you remember, right? Supply and then receipts. Transport supply is from a shipping location. Transport receipts is from a receiving location. So transport receipts is more with lead time offsets and etc etc. So like, we have seen it. So we have in total there are 12 key figures, but like in like from constraining perspective, there are eight key figures. So first two bunch are related to the customer receipts. Minimum aggregate customer receipts, maximum aggregate customer receipts. Next bunch is minimum aggregate production receipts, maximum aggregate production receipts. The next bunch is about the transportation. Minimum aggregate transportation receipts, maximum aggregate transportation receipts. Then we have minimum aggregate inventory, maximum aggregate inventory. So if you have observed, so the core supply plan, the supply plan gives a lot of results, but there are four key things that the supply gives. That is demand fulfillments, how much is been shipping to the customer, so that is called as a customer receipts. So that, for that supply planning output, to influence that part of the supply planning output, we have the first set of key figures. To influence the production plan, you have these two key figures: minimum aggregate production, maximum aggregate production. To influence the transportation, we have these three: minimum aggregate transport, maximum aggregate transport. And to influence the projected stocks, we have minimum aggregate inventory and maximum aggregate inventory. And now you can ask a question that I have also seen another min and max key figures, like minimum production receipts and maximum production receipts. What's the difference between that and this? So yes, there is a naming convention is different. I could see an aggregate coming into the picture, but like, what is a core difference? The core difference is that the minimum production receipts has to be maintained at its base planning level. What is a base planning level of minimum aggregate? um, so there is a key figure called minimum production receipts. So this is at week prod log source ID. That means for every week, on every product, at every location, and on that particular source ID, we can maintain this minimum production receipts. But the minimum aggregate production receipts, this could be maintained at any level, or I would say at any aggregated level. Okay, so like, what does it mean? So here, if you come and then you say that in plant one, so let's say there is a particular product called S12, and then S12 there is two bombs that are available, two production versions. So that's called PV001 and PV002. So for this product, the demand is 1000, let's say, and then when you run the optimizer, 1000 would be sent to DC here. So the DC gets 1000 here, and now optimizer either produces from plant 1 or plant 2, or you have a co-packer here, or it does something from the co-packer as per the costs that you maintain, capacities available, etc, etc. But now if you maintain that my minimum production receipts for PV001, if it is 100, or let's say not 100, let's say, you know, 90. So system would do a minimum of 90 on this particular production version in this plan for this product. It says that produce 90, and remaining 910 would be sourced from either here, or maybe from a different production version here, or maybe from here, or etc, or maybe completely can be done from the production version 1 itself. So we never know, but a minimum of 90 would be produced from plant 1 and on this particular production version. So that's the case with the minimum production receipt. Now when I talk about the minimum ag, so I can just say that at an aggregated level. So I'll say the minimum ag production for the product S12, or let's say if I say the max, let's say max, if the max ag production for product S12, if I say it is 0, you know what happens? So you kept a condition at an aggregated level that this S12 production should be 0. Maximum is 0. That means in your entire supply chain network, S12 product will not be produced by any location on any production version, be it co-packer, anyone. So the production becomes 0. That's the power of the aggregated key figures. Okay, and it can be maintained at any level. So same is a case with the other key figures, like let's say minimum aggregate customer receipts. This is more from a customer perspective. So now you will say that for this Amazon, you will say that minimum aggregate customer receipts. So now here you will not even mention any product, and you will just say for the Amazon, the minimum has to be 5,000. So now irrespective of all the products, because you here you're not mentioning about the product, here you're just mentioning the customer Amazon. So now system would respect this 5,000. So when we actually sum up the entire supply plan, the customer receipts, and when we sum it up, it becomes 5,000. So I hope you guys, I hope you're following. So you're following it, right?
Yeah, Venkat.
Sure. Yeah, great. So let's read the theory.
So,
Um, minimum
yeah, Venkat.
aggregate.
Hey,
Yes.
sorry to interrupt, Venkat.
Sure, sure. Yeah, please go on.
Uh, yeah, these are key figures. I mean, at least my understanding is a little bit clear on this. What I
Hmm.
wanted to know is, how do we set up the master data, right? Because the way, we set up master data in aggregate planning, it's different than the regular, planning, right? Key figures, they are somewhat the same, but the way they have used for the calculation, or to show the planning is different. That I understand. I mean, at least a little bit, I'm aware of that. But the
Hmm.
master data setup is different, right? The way you set up your location, your product location, right? Customer,
Yes,
product,
yes, yes,
that
yes,
one is
got it.
different.
Yeah, got it.
Yeah.
So, Amal, I know. So we actually try to replicate whatever is there in APO in one of my IBP implementations, the group planning concept. Um, so that is not been supported in IBP. So here we have to live with the key figures, and so. But you asked about the master data, like how to deal with the master data. So there is no any separate master data for it. So we have to be, you know, it's all about the planning level of your key figure. That means at what level you want to constrain on. So now, for example, let me quickly take you some custom scenarios. I want to say. So let's say there is we are into this automobile manufacturing, so we have 6 different SKUs. So the product subfamily is a hatchback, sedan, and a van. So these are 6 different SKUs, and they belongs to a separate product group called hatchback, and sedan belongs to SUV product group, and then van belongs to MUV, multi-utility vehicle. And now SUV and MUV both belongs to commercial vehicles, which is a product family. So this is a product hierarchy first we have to create in the product master data. So that is anyway available in our in the product master data. So so now what I'm saying is that your aggregate key figures, so we have to decide at what level you want to constrain on. So are you, or do you want to constrain at a product level, or a family, or a group, or a subfamily, group, or a family? So now if you think that I would be constraining more at a product group level. So now we'll create this min ag production at a level. So there is all, if I figure there's a level, right? So in this level, if this is a planning level, we make sure that we include the product group here. So planner will always see a product group. So now planner will go and he'll say that SUV, and then he'll say that the minimum aggregate should be, like 5,000. So minimum you have to produce 5,000, the product group of SUV. So now if you say 5,000, system might produce all 5,000 of this product, of this SKU, or maybe this and this, or maybe in total. So but the total sum would always be 5,000 for that particular week. So now the next question. So then there is always this location dimension. What about the location? So you're saying that in what location I have to say. So for that here, when we load the value, what we load is, here we'll say underscore ns. So that means, what does this underscore ns means? This means not specified. That means planner wish not to specify any location. So planner want to just constrain on the product group level, that is SUV. So my SUVs, I should produce a minimum of 5,000. And locations, I don't care. I don't know. There's also another dimension called source ID. Which bomb, I don't know. I don't care. I'll just give only PG, no, sorry, product group as SUV underscore NS, and then I maintain 5,000. Now underscore NS acts as a wildcard. So now the system can pick anything. System can pick plant 1, plant 2, plant 3, or maybe co-packer, or maybe anything. But the production would be 5,000. So now what is the key here in maintaining these aggregated constraints? And aggregated constraints are a hard constraint. So they will always be met only when these hard constraints collide with another hard constraint. What is the other hard constraint? That is the capacity supply, usually available capacity. So now if you say minimum is 20,000, if the total production can happen only for 10,000, your your constraint will not be respected. So you will end up getting only 10,000, even though your minimum is 20,000. So the conflict will always be there. So that's a thing. But here what I'm trying to highlight is the planning level is a key. At what level we have to configure this key figure, number one. And number two, once the planning level is ready, at what level the planner actually wants to maintain. That planner can actually go and he maintains underscore underscore ns, and then he maintains the data, and then he runs it, and system would respect the value. Okay, now he can also maintain commercial vehicle, or he can so etc. So let's assume that the one plant is producing all these products, all the 6 products. So now here you can say this plant and MUV is 0, the maximum is 0. So now what happens? The plant will not produce any of the MUV product group SKUs. That means this van 1 and van 2, they will not be produced because the maximum is 0. So that's how we have to interpret the key figures, and then we have to live with the planning levels. But from a master data perspective, we're not doing anything new, we're not recreating. So I know that in APO we kind of logically combine everything, and then we create some kind of a phantom a product group, and then we create a phantom kind of bomb for that, routing for that, and now we actually that is a group, the logical grouping of the actual SKUs, right? And then we do the supply run on that group level, and then we'll get the results at that group level. So that's the thing with the APO. So but here we don't need to create some custom master data. We can actually live with the existing master data, but the planning level we can create any level, and then we can deal with that. So now let's see the other example. So now here I have inside my plant, so there is this plant. So this plant, 6 queues are getting produced, all SUVs, MUVs and vans, all 6 queues. So there are 2 lines, robotic assembler, and another is so let's say this is one line 1. So there is a robotic assembler, and then there is robotic painter, and then in the line 2 there is a manual assembler, and then there is a manual paint machine. Okay, so now all these source IDs passes through these 2 different machines. Now this R1, resource 1, resource 2 belongs to a resource group called robotic production line. Resource 3, resource 4 belongs to a resource group called manual production line. So now what we can do is we can take this resource group and attach it to our minimum to our minimum aggregate production receipts key figure, and then we can actually constrain like here we talked that I'm going to constrain at the product group level, that is SUB. Just like that, if we can actually in the planning level, if we can bring up another attribute that is called RG, that is resource group. Resource group is a consisting of assembler and then the paint machine. So now here I'll say my robotic assembler, the minimum has to be 5,000. So now what system does? So all the bombs that goes inside these 2 resources, system will give a production plan of 5,000. And manual assembler, if there is no demand, system will not do anything on manual assembler. So what are we doing here? We are actually prioritizing our resource groups, and we are telling it to the system that produce more from my resource group 1, that is my robotic resource group. Using what? Using these aggregated key figures. Resource group, is this a standard one? No, it's a custom made. So it's just an attribute that we have created, and then we mapped it is like it's kind of a Z field. We map it to our resource master data, and then that we are using in our aggregated key figure planning. Can I do the same for the standard minimum production receipts, etc.? No, system would fail, because you cannot actually introduce you cannot constrain data custom attribute in the standard supply planning key figures. But whereas with aggregated, you can actually maintain them. So let's go quickly read this. Modeling a production constraint at a resource group level, which is custom planning attribute. So this is the one that I'm saying. So I'm again coming back to the planning level only. So aggregated key figures. The planning level is a key. At what level you want to constrain on. So, and that would be at the aggregated level. So it's not just a detail level. So it could be any level. So in your hierarchy. So that hierarchy, you can also create a custom one. Below diagram depicts that 6 queues belonging to various product families that gets manufactured in a plant location. There are 4 resources available in the plant where all SKUs production versions will go through these, or when R2 resources or on the robotic production line. R3 and R4 will be processed on the manual production line. With a custom configuration in place, we can model a production constraint on this resource group level, say robotic production line. So yeah, so that's the thing with let's go and quickly do a demo, and then we'll get into the forecast consumption. Same simple Amazon customer connected to a DC, 2 plants, plant 1, plant 2, and then there is a co-packer. And then we have a product called S12, and then the simple product with 3 transportation lanes and everything is fine. But now here we'll introduce some aggregated constraints, and then we'll see how it works. I So let me actually show you in how the aggregated key figures would look like. So it depends on like what kind of a key figure that you want to use. You don't have to use all aggregated key figures. So, but for sure, what I'm aware is that in what I have seen is that aggregate productions and aggregate inventory is what has been heavily used by the businesses. Like aggregate inventory is used to actually constrain your restrict your projected stocks. So if you say that my maximum aggregate inventory for this product family is 0, that means system will not keep any stock lying for that particular product family across your supply chain network. If you say that if you say that all other locations you don't specify, that means if you say that underscore ns is for the locations, that means you're not specifying them, they will act as a wildcard. why it is taking so much time. I don't know what happened to the system. Is there any? Okay, Amal, can you see my screen?
Yeah, Venkat, I can.
So here, this minimum production and then aggregated constraint, there is this checkbox. The checkbox is turned on, so that means um, it's 1 second. That means it's an aggregated constraint, and then here we'll see the base planning level is this Calvik prod log source SRC ag. So now if I go to this planning level, and this is standard, I haven't touched anything, but as I told that it can be tweaked. We can actually include the custom attributes that we want into it. So yeah, I don't know why it is taking a lot of time. And then here you will see that input or output for supply planning here. So it is an input for supply planning. I don't know why this is taking so much time. Hey, just give me a minute, Amul. Just give me a minute.
Okay.
Yeah, finally this is open. I don't know why this is taking so much time. But let's go from a different route. There's a different app called the Planning Areas app. So I think that would be hope that works. This is one planning area 324. This the interface is much cleaner in here, but the actual core configuration has to be done from this app. So mm, so finally it opened. This Cal Week product lock SRC ag that is being used by the max ag production and min ag production. So as I'm telling that planning level is a key, and then we should include the right attributes into it, like whichever we want to use. So And then one more thing is that there is no time level constraining in here. So just like the way we are constraining at product group or location group or etc., we cannot actually constrain at a time level. So I mean to say that you cannot say that my December 2019 production has to be 5,000 or something. So and if you keep it at a monthly level 5,000, so system would give a production plan, and then if you actually sum up all your 31 days of December, um, it should be minimum of 5,000. So if that is your expectation, no, it cannot be done. It should be only at a weekly level or maybe at a daily level. Like I mean, but it's just only at one time level that you want to configure. So you cannot actually do from a time perspective. You cannot actually do any constraining. So add constraint is a dummy master data. If you want, you can just maintain. So this is where you want to know where you actually number your constraints. Like you're getting right. I mean, you maintain multiple constraints. So one constraint is at a product family level. Another constraint is at location group level. I'm talking about a same production receipts key figure. So for the same min ag production, max ag production, you would be constraining at multiple levels. So that's the thing. So but if you want to know that what all constraints you maintain, you can actually use this ag constraint master data. This is where you mention the naming, like ag 1, I mean constraint 1, constraint 2, constraint 3, so that you can also refer it back with its own name. And then under the locations, three attributes have been selected. One is location ID, region, and type. So um, so like this is a standard. As I'm telling, you can easily unselect location type here and then bring another one. So why location type is there? So let's say you have co-packers. Let's say you have multiple co-packers and you have your in-house productions happening. So the co-packers also does some production. But if you want to constrain on your co-packer type of locations, so now what you can do is you want to maintain your max ag production as 0, and you will say that location type is co-packer. So now what happens? Across your co-packers, the productions become 0. So you know that's how you can utilize the location type. And also location region. So you can use a particular region and then you can say across this region, the production should be 0 or something like that. And then the fourth master data is product master data. So here the standard hierarchies, that is product family, product group, and then product subfamily was being selected. And under the source production, so there is source ID and then there is a source type. So source ID and the bomb number, and then source type is whether it's a P and stuff. So this is a standard. You can very well take off this master data, and then you can add the things, and then you can add custom attributes, and then you can save it, and then you can start planning on it. It is still taking a lot of time. So let me actually tell you that like how to keep multiple constraints. So as it is taking some time, so now here in the max ag so here you can say that this is the product family, and then this is a location ID, and then this is a key figure, and this is a value. So now here So here, let's say you have this structure. Now the first constraint you're going to enter is that, okay, I have a product family, commercial vehicles. You'll say that my commercial vehicles, product subfamily, I don't care, NSNS. Location ID, I don't care, NSNS. Maximum has to be 5,000. Like this is week 35 of 2019. Okay. Now, if you do this, now what system does is product ID, location ID, and then source ID. So I don't know. So let's say car one is your product, and this is plant one, and then this is a car PV001. And the key figure is production receipt. So remember, this is the one, and then um, this is car two, and then this is plant one, and then this is. So supply planning result, if you keep a constraint like this, it would come like this. Okay, just saying. Production plan across three SKUs: product one, car two, car three, across the locations, plant one, plant two, across the source IDs. This is the production receipts, and if you sum this up, it becomes 5,000. You there, Amul?
Yeah, Venkat.
Amul, you there?
So, I mean, I was just trying to, yeah.
Amul?
Hello, can you hear me,
Hey,
Venkat?
Amul, can you hear me?
I can hear you, Venkat. Can you hear me? Hello, Venkat, I can hear you.
Hey, Amul, you there?
Yeah, Venkat, I'm here.
Okay, okay, sorry.
Hello.
Maybe, yeah. I can hear you. Maybe my issue. So now you understood this, right? So I kept a max ag at the
Yeah,
commercial vehicles. Okay. So now what I'm saying is that you
but
can keep
Venkat,
multiple.
just quick thing, on this, Yeah, I mean, this aggregate planning, I mean, the way, you're showing in your example, yeah, it's completely fine. I mean, yeah, you can actually, plan it at the higher level of the hierarchy, basically, for the SKU, right?
Mhm,
But the way, the way, I used, is basically, the aggregate at the location level. What I mean
mm,
to say by that is, uh, we have one SKU, right? And we have multiple locations, like multiple DCs, right? Then we
mm,
have one plant.
mhm,
So, if you run any planning engine basically on this queue, where you
mm,
have two or three, DCs, and then just one plant, so what happens, each DC, the planning engine basically considers each DC's demand, supply, and all, and each DC,
mhm,
propagates that demand, the remaining demand, unconfirmed one, or I would say, uh, the shortages basically, each DC, with the shortage, it basically, propagates to the plant, right?
mhm,
But what we do in aggregate, the way, I use it, so we aggregate that shortages, from all those three DCs basically, right?
mm,
That demand,
mm,
and then we propagate that shortage to your plant. So instead of, getting shortages from each DC, we
mm,
just, calculate the net demand, on those three DCs basically, and only netted demand, we basically send to plant. Otherwise, in our regular scenarios, where aggregate is not there, we just,
Hmm.
demand from each DC individually, right? And then it
Okay,
tries to fulfill that demand.
sure.
So I mean
So
the
you,
way
so
I've used that, it's a little different. I mean
okay,
this is also, oh yeah, I mean part of aggregate planning only, but I was just trying to
okay,
see. Yeah.
cool, got it. Okay, got it. So yeah, so you're saying that the DC has already some stock lying, so there is no point of pushing the demand to the plant. So if the DC has 1,000, the demand is 2,000, push only 1,000 to the plant because you already have 1,000 with you. Is that the thing that you're saying? Hello, Amul.
Correct. Yeah, because see, I mean, doesn't make sense to,
Yeah, I can't hear you.
uh,
Mhm. Hello. Yeah, there's a lot of disturbance coming in, Amul. I mean, maybe issues with my side, even though I can see full signal here. So your voice is breaking. Um, yeah.
okay, no
Okay.
problem. Venkat, just continue. I mean, yeah, we can
Yeah, I mean, as
discuss.
long as
Yeah.
as long as you can hear me, yeah. So anyway, I'm going to stop in here because for forecast consumption, I have to actually get into the system and run the algorithms. Maybe let's connect tomorrow. For now, I'm just want to wind it out. So just want to highlight on one other thing here. Um, when you keep a constraint at a very aggregated level, that is commercial vehicles is at the top. That below that we have a product group and product subfamily. So now what I'm trying to say is you can actually maintain multiple constraints on under single constraint. So let's say that car 3 belongs to a product subfamily called van. So now you also wanted to uh, constrain at this. So what you will see here is you will say it is van, and now here you will say this is underscore underscore ns. Now location id also you don't care, underscore underscore ns. Now here you will say minimum ag production. So here you will say that minimum has to be 3,000. So now what happens is that you are introducing two constraints. One is at a very top level, commercial vehicles has to be 5,000, and at a bit detailed level, that is at subfamily van, you should do a minimum of 3,000. So now what system does is all the SKUs that belongs to the product subfamily. And in our example, car 3 is the one that belongs to the product subfamily. And then now here it does 3,000 here. And then it will adjust for the others. So this is what it comes. So system fulfills both. First, system fulfills this constraint, that is at van minimum it has to do 3,000. So there is one product, that is car 3 under van family. It did 3,000 there. The second constraint is total it should do 5,000 at a commercial high vehicles level. So now if I sum up all this all becomes 5,000. So that way we can keep multiple constraints on the same key figure and under the same constraint. So we can get the desired supply plan that we want. And yeah, so let's not proceed further because I don't know what's wrong. Maybe I need to look into it, maybe delete some cache or maybe fix something. So let's regroup tomorrow, and then tomorrow we'll touch base on the forecast consumption mode. Okay.
Okay, Venkat. Yeah, thank
Sure,
you.
sure, Amal. Yeah, yeah. Thanks.